I'm Christian Chiller. Welcome to my podcast, an enthusiastic ramble through whatever has taken my interest the past week or so. Expect technology, games, history, travel, geekery, and as always, much, much more. So on this Chinchilla Squeaks, I have been joined by Barak from Scribe Security. And this came up after actually a previous episode when I talked to Open UK. And also this has come up a few times with post-KubeCon as well. This subject of SBOMs. Despite the I still personally think, rather odd sounding an acronym. What is an SBOM? That's kind of what we're here to talk about. But maybe let's start with a little bit of an introduction to yourself and the company first.
Well, like you said, my name is Barak Brudo, and I work as the DevRel for Scribe Security. Scribe Security is a company who made it a target to deal with software supply chain security. Mm-hmm. Now, for those of our listeners who are not sure exactly what that means, the idea of the software supply chain is that since most code these days is not actually written by, let's call it a developing company, but it's actually composed of various bits and pieces of open source. If you follow that idea, to its logical conclusion, that means that you bring in open source packages, and when they develop those packages, they themselves use open source packages, and so on and so forth. Yeah. So in effect, when you bring something into your project, there's actually no easy or relevantly transparent way to see everything that you're actually including. Mm-hmm. That makes it a problem, obviously, especially if somewhere down the line there's a little hidden problem that is just waiting to rear its ugly head. Yeah. So what Scribe Security is doing is developing a tool to help you increase both visibility and give you trust by verifying integrity. One of our main tools to do that is the SBOM. Mm-hmm. Now, because, again, a lot of people would not necessarily know what that acronym means. An SBOM is a software bill of materials. Yeah. Just like any other bill of materials, when you think about the bill of materials, you think about this big list of possibly big boxes in the back of a truck. What's in there when you're delivering it to a warehouse, or some other sort of list that itemizes something. Essentially, a software bill of materials is exactly that, except it itemizes, tells you exactly what is in a piece of software. It can be a singular artifact. It can be something a little more complex, but essentially the SBOM would tell you exactly what files and packages are in that software, including exact identifiers, version numbers, the license that is being used by those pieces of software, the relationships between those files and packages, so that essentially if you have that along with a piece of software, you have far greater visibility into what it is you actually received.
I mean, maybe to someone like you and a company like this seems not as new. But why now? Why do you think this conversation is happening so much, seemingly in this year? I don't know if that's really true, but as far as I can tell, I've heard a lot of it in the past few months. And why now, do you think?
Well, I don't think I know. Well, if you wanted the shortened version of the historical chain of events, 2020 was a big year in terms of software supply chain events. There was SolarWinds. I'm sure everybody who's listening has heard about it. They may not know all the details, but when you say SolarWinds, it immediately brings to mind something bad happening. It was big. It was impactful. It was on the news for a long time. Mm-hmm. That was 2020. 2021, following that, and the fact that it affected 9 separate federal agencies, which is even worse, the Biden administration released an executive order whose title was to improve the nation's cybersecurity. The number, to those who want to follow, is 14028. Among other things, that executive order mentioned SBOM by name. It told NIST to create a framework to tell companies exactly what it is they need to do to improve the software supply chain in general and the cybersecurity, all over. They did that. SBOM is again mentioned by name. So because the executive order and the SSDF, the Secure Software Development Framework that followed it, are now meant to be implemented across the board, especially if you want to do any sort of business with the federal government, that means that more and more companies are looking at this as not only a way to improve their security or their visibility, but also as a way to being included in any sort of future business. And of course, once something becomes standard or best practice, obviously it's wanted to be included everywhere. CISA and NIST and lots of other federal agencies are now pushing hard to include the SBOM with everything because it's a best practice. It's a good idea. Yeah. Because if you think about it, even something that was recently famous, like Log4Shell, or even more recently, Colors. One of the big problems with some of those vulnerabilities is that you don't know if you have that package or that version, and if you do, where is it? If there was an SBOM shipped out with every piece of software, it's just a matter of looking it up. Just a simple, text search. That string with that version number, do I have it? If you do, you'll be able to see it in the SBOM. You'll see exactly where it is because you'll have the relative path. That's it. Search over. You know if you have it, you know where it is. The fact that you could have that sort of itemized list means that if you match it with another automated tool that connects, for example, to a list of CVEs or vulnerabilities, once you have that, if that vulnerability database knows to look for that string and that version number, suddenly you can pass it SBOMs and get back a response, yes, this is clean, or no, this has this and that problems. Makes things a lot easier, like I said, more transparent and more trustworthy. The fact that without an SBOM, you could conceivably receive a piece of software that uses legacy code because nobody ever bothered to change it and it works, that is a problem. Trust but verify is no longer just an empty, platitude. It becomes a need, especially in these days with, like I said, increasing problems with software supply chain security, nations employing hackers and groups that are more and more active in the world front to both disrupt everything and, out for themselves to make money. The fact that you can't trust the software that you receive, even from large corporations like Google or Microsoft that had their own problems recently with Chrome and other releases, means that if you can verify it for yourself using a tool like an SBOM, it's much easier and better than expecting people to take your word for it, that you did everything you could.
Well, I would imagine there's quite a few questions that came out of that answer. Sure. I would imagine that in certain sectors, this is going to become more and more of a necessity, not even just a nice to have. And maybe, with bodies like the EU, for example, it could even become regulated at some point. So get ahead of the curve, I guess. But I would imagine like government and sensitive areas, some people are probably already asking for it, and others they might all be asking for it soon.
The beautiful thing about the idea behind the software supply chain is that if you are a company that is required to present the SBOM, like I said, everything is composed of other parts. That means that if you need to present an SBOM, you need everybody that contributes to you, that sells you parts, that gives you pieces of software, to give you those SBOMs as well. And they need to do that with their eventual suppliers. So the trickle-down idea is definitely real here. If you need an SBOM at any sort of high level, eventually it's going to be needed by everybody.
So I want to ask I want to get to answer that in a bit more detail in a minute, but I want to ask something else first. So, I mean, in abstract, obviously with Scribe, you have one way, with open source tools, you have another way, et cetera, et cetera, et cetera. But what do you anticipate a software bill of materials kind of looking like? And how do people get it? Is it literally just a text file or a PDF people are going to submit? Or, what is it? Do you think there's going to be a standard around this, or it's very much who you use?
Well, again, I don't need to think because I know there are already standards. The two big ones are Cyclone DX and SPDX. That's the two big standards that are currently being worked on. Obviously, when you talk about something like this that wants to or aims to be standardized across the industry, if everybody was doing their own version, that kind of makes it a problem for having something that eventually you want to be machine readable. If you want it machine readable, if you want a standard, That means some sort of build that everybody agrees on.
Yeah.
The NTIA, which is another acronym from the US, has created a document quite a few years ago that names a minimum of 7 requirements from any sort of SBOM document. Most SBOM documents come in the form of JSON files.
Okay.
A couple of the big things that they need to include, for example, is when they were created, by whom, file names, hashes, version numbers, unique identifiers, relationships between different elements, that sort of thing.
Yeah.
Of course, the more information you can include, and you can include a lot, the better it is. If I remember correctly, SPDX, as mentioned in the NTIA documentation, can include up to 43 different types of relationships between files. Obviously, the most obvious is a dependency, as in this file or package is dependent on this one or requires that one as a dependency. But there's lots of other types of relationships, like this file was created as a result of a test on this file, or this file was created when these two files were combined. This file was deleted. This one is a log. There's lots of different types of relationships. So again, the idea is that you create something that is standardized. It includes, at minimum, all of the stuff that NTIA requires. You can add additional details, but you have to keep a certain structure, which is, again, mostly or usually a JSON file structure, so that it's easy for a code or a machine or whatever it is you want to build to look at it, understand it, search different parts of it, and so on. There are lots of other questions, obviously, but for now, the two big, let's call it entities that are working on these standards are the Linux Foundation and OWAAP.
Okay.
I think I said that correctly. I can't remember.
I think I remember who you mean, yeah. So I can imagine with open source dependencies, this is relatively easy. They generally have nothing intentionally to hide, et cetera, et cetera. Getting public information is pretty straightforward. But with proprietary dependencies, how would that differ? And do you anticipate any? I kind of imagine some people not wanting to reveal those, and how's that gonna work?
Well, that's one of the things that is, I think, the beauty of an SBOM, because an SBOM gives you file names and package names, but it doesn't need to look at your code. I mean, if you know that a certain file has a name like index.html, lots of different software has that file. You can list it and whatever dependencies it might have. It doesn't actually tell you what's in there. That is extremely relevant when you think about corporations that have IP concerns or military secrets or, intelligence concerns, anything like that. An SBOM doesn't actually look at your code. It doesn't need to. All it does is list file name, package names, and version numbers. When you run an SBOM on your own system, it obviously has access to everything that you have. When you publish it, it gives file names. So unless you name a certain file, this is my secret recipe, do not reveal, and basically target it for everybody who wants to go into your system and look for it, you're fine. Most file names would have extremely obtuse names that would include numbers and letters and various combinations. And unless somebody is extremely in the know, they would have no real way of knowing whether this is important or whether you made any sort of changes to that particular package, which was open source. You downloaded it and then you included it somewhere in your code. It doesn't say any of that thing. All it does is gives you the name, the version, a unique identifier, and a hash. The hash part is another really cool part, because companies like Scribe can use that hash to check for integrity. As you know, a hash would change if you change anything, even the most minute detail in a file. So I don't need to know the code. I don't need to look at the file. All I need is look at the hashes. If I have two SBOMs and theoretically the same file or package and the hashes are different, that is a red flag. That means something is different. And again, that same principle holds for open source. Open source, like you said, is open. It's out there. It's on the web. I can look at what it's supposed to look like, look at what it looks like on your software. If they're the same, great. You use the open source as it's meant to. If it's not the same, either you made changes on your own, and that's fine, or you got a corrupted version, you downloaded it from somewhere you weren't supposed to, that sort of thing. So again, it gives you visibility and the ability to check things for yourself without having to trust somebody else's word.
So I just like to maybe clarify, maybe a misunderstanding I'm having, but is this intended to show that the actual software bill of materials? I imagine that platforms like Scribe probably do more on top of this, but yeah. Is it just like verifying sources, or is it more than that?
Well, again, the idea is to give you visibility and allow other people to get that information. There are various uses that you can have with that tool, but whatever you decide to use it for is up to you. It's essentially a tool. For example, I already mentioned several uses. One, if there's a known vulnerability, you want to check if you have it. If you have a software bill of materials, you can do that easily. If you are concerned about license poisoning, a lot of open source packages have licenses that mean that if you use them, everything they're used in becomes open source in turn. If you want to verify all the dependencies and sub-dependencies and so on, all the way down the chain, and SBOM is pretty much the only way to do that, unless you sit a team of people to dig through your code and constantly update that list, which, I'm sure some people are still doing it, but it's not the most efficient way of resolving that issue. And there are other uses, but like verifying if you're, for example, medical hardware supplier and you're selling your stuff to a hospital, the hospital want to make sure that whatever they're going to get and then move to patients in turn does not include known vulnerabilities, legacy code. So it gives basically the power to you as the company using it to check for things, to verify things. If something breaks in a certain version, you can check, this current SBOM with the previous one, know exactly what changed, what version, what files, and you have a lead as to the problem. So it gives both the company who's using it tools to do something with various cases, and the receiving end, the client, the reseller, tools to know exactly what it is they're getting their hands on, and in turn do their own tests if they need to or want to before they're moving it on to a final client. And of course, even if you're a final client, if you get that SBOM, it gives you more visibility into what it is you're actually getting. Let's take a very, very extreme example. Let's say that you live in a country that has problem with a lot of the rest of the world. I don't know, maybe you live in North Korea, and you don't want to accept any open source packages from the hated enemy in the US. If you accept a piece of software with an SBOM, you can easily see all the open source included and where it came from and who the developer was. And you can decide not to accept anything that was manufactured by anybody from North America. Let's say even something smaller. You had a fight with somebody who manufactures open source packages, and you absolutely do not want to use any of those packages that person would ever create or anything like that. These days, unless you have other tools to check for dependencies all the way down the chain, and there are other such tools, there's no easy way to do that.
It starts to help enforce the slightly controversial but relevant to too many people, like ethical licenses. I don't want software created by certain companies or people, et cetera,
or nations. I don't know.
Yeah. So I can understand. I think one more question on the standard, then we'll dig a little bit more into Scribe. I'm still I understand on something I might install or download how this could work, but if it's like a cloud-based service, is that going to be something possible or not? And they're hosted on Google Cloud, and Google Cloud has a vulnerability. Like, how is that kind of relationship going to work? Which can be just as problematic, but very intransparent a lot of the time.
Well, the current standard, the current build of SBOMs works on mostly monolithic software artifacts.
Okay. Yeah.
Mostly. That means that if you have a distributed system, if you have microservices, if your service or software is extremely distributed, it's going to be extremely difficult to make an SBOM for it because everything is everywhere. That means that at least at the way things stand right now, that is a problem, at least in terms of the SBOM. People are working on it. There are committees. There are public forums. There are work groups. People are working on this. Eventually, the idea is that every piece of software everywhere would come with a software bill of materials. Right now, one of the, let's call it workarounds, is that any artifact can create an SBOM for that particular artifact. And whatever parts you don't know or you don't know about, or it links to something you don't know about, you can just put in unknown. That gives you something. It's not full coverage, but it is something. Yeah. And yes, it is a known deficiency of the SBOM as it currently stands, that it doesn't work well with distributed or extremely distributed systems.
Yeah. Okay. Yep. And so let's get to Scribe. What's the history of the company? Why did it set up? Was it already doing something before, and this is kind of a branch out, or is it explicitly set up to work with these SBOM standards? Yeah.
Well, Scribe is extremely young. It's only slightly more than 1 year old, which means it's slightly older than my son, but not by much. It came to be around June of 2021, which is last year, right after the executive order came to be, which was May of last year. When that executive order came out, the founders of the company realized this was essentially pretty much a new field, which had a lot of potential for growth, especially because what they saw, what they envisioned, was that these standards and requirements are not going to be limited to the US and not going to be limited in time. It's essentially building a new field in cybersecurity. So they decided to, get a head start on the bandwagon, as it were, and they started to build this idea of a solution. Now, the SBOM is only part of it. What makes Scribe unique is the fact that on top of the SBOM, they're adding integrity verification, which is something that not a lot of other companies are including. Essentially, the idea is that let's assume that an attack has already happened. You don't know that. Most people wouldn't be able to tell that at any sort of reasonable time frame. What Scribe is doing is it's looking for the aftermath. The thing that we're trying to secure against is changes which happen somewhere along your software supply chain. Either somebody got in through your CI/CD pipeline or made some changes in your code through a distant dependency, that sort of thing. So any of those events means changes to the code. Remember I talked about hashes and SBOMs? We take SBOMs at several points along the pipeline, beginning and somewhere in the middle, and we compare file hashes. If they're the same, everything is fine. If we find differences, however, that's a red flag. That means something somewhere is different. We don't need to know why it's different. We don't need to know, what happened. All we do is tell the person who's running that report, hey, you better check this out. Something is different, where something is not supposed to be different. Most of the time, everything is fine, which means that you, as the company who's running this tool, gets to give a stamp of approval to your eventual client or whoever is looking at this. What you're getting is the exact code that we as a company have intended you to get. Nothing more, nothing less, nothing is different. And that is both true for our source code and our open source dependencies. Everything is as it should be. Doesn't mean there are no problems. Doesn't mean there are no CVEs because, we don't check that. Yeah. It's in your code. We don't look at your code. All it means is whatever it is you intended to ship out, we guarantee that's exactly what you ship out.
Yeah. And I notice at the moment, it's fairly early days, you support Node containers only. I would assume then that certain languages and certain technologies is easier to get dependencies than others. Node is a bit of a cliche about its dependency tangle, but at least it has a system.
It's just that we had to choose some point to start.
Yeah.
And Node and NPM seemed like the obvious starting point. The thing about different languages, different package managers, is that every different language compiles things differently. Now, of course, I can say, sure, we take SBOMs, we compare hashes, and that sounds very flippant and easy. It really isn't, because if you think about the compilation process of a piece of code, things move, things change, path has changed, sometimes names change. So to be able to say this file in the final product and this file in the source is the same file, and we should compare them and check that they're the same, takes a lot of work. So that's why we decided on a certain language to begin with and a certain package manager, which is NPM. Eventually, we're going to add additional package managers, additional languages, but that every additional language and package manager is additional work on our algorithm.
Yeah.
And obviously, the more people use it, the more information we can get, and the better the algorithm would be. If, for example, and these are not actual numbers, they're just, ballpark numbers. Let's say that right now we have, 88% accuracy. The more people use this, the better we can train our algorithm, the better we can find edge cases and make the accuracy of the comparison even greater. Because there are always going to be certain edge cases of files that are just, we don't know where they came from. They could have been created as some sort of test somewhere along the compilation, or a log file that was created somewhere. There are always going to be edge cases that we don't know what this file is. The idea is that the more people use it, the smaller that those edge cases are going to be. We aim to get as close as possible to 100% coverage on all the files in your final artifact, Docker image, whatever it may be.
Mm-hmm. And assuming I would confidently assume you've tested this quite a lot. What are some of the biggest surprises you've found testing this on various software and generating bills of materials? What surprised you?
Well, I can't go into too many details.
Yeah, for sure.
All I can give you some teases. I can say that because our system depends on a database of sorts of open source packages, which is a sort of source of truth for us in terms of open source, we had a little bit of a problem or an interesting conundrum when we came to work with some big names in security, because obviously these companies require everything to be offline. They're not connected to the internet infrastructure, and yet they wanted to use our system to verify things. That made it a bit of a problem. We managed to work around it. There are various other bits and pieces that we had to dance around to make sure everything is secure, but they were interested exactly because we're not looking at their code, and they could employ the same solution to their suppliers. They just told their suppliers, use that, so we get the SBOM, we get the verification that everything is as it should be, so that we know everything is kosher. So they employed it both internally and externally. That was one thing that was interesting. The other is that when I was working on a lecture about the SBOM a couple of months back, I created SBOMs on several large images, well-known ones from Artifactory. And just as an exercise, I did a search on Log4Shell. That was in, I think, April, which is about 5 months after Log4Shell was initially discovered. I still found it in a few places.
Oh, for sure.
I can also say that after a lecture on Log4Shell, which I participated in, I listened to a security expert talk about the amount of work that his team did on helping a company find out where it is and if an attack happened and how to mitigate it. After that lecture, I asked him, tell me, if that company could have given you an itemized list of all their files and packages with relative paths, would that have helped you deal with the problem? And he said, well, yeah, because finding out if they had it and where was most of the work. That was most of the problem. And we had to wait for an attack to happen to be able to trace it to the source. They had so many servers and so many different types of software on those that going over everything would have taken years. There's no way for us to have done that. So we had to wait for an attack to happen just to see if they even had that vulnerability. So those are some anecdotes from our recent work. I can't obviously go into too many details because our design partners are design partners particularly because they want to maintain anonymity.
For sure. Okay, so the company's pretty new. I think you've got a fair bit to work through, but what's the next on the most immediate roadmap? What are you working on in the next few months?
Well, the part that I told you about, which is the SBOM, the integrity report, that's basically the small potato. This is like the lowest level that we aim for. Scribe is thinking big. They're thinking of creating an ecosystem in which you can go into a sort of marketplace, search about every company you can imagine, and see that not only do they have an SBOM, but you can check that whatever security steps they took, and that everything is verified. You can verify provenance. You can check for attestations. Everything would be documented in an immutable database, and you can just check for it and satisfy your curiosity that everything is as it should be. So one of the first steps that Scribe is currently working on is creating something that is called a Scribe Hub, where if you're a company, obviously we're talking about a bigger level company than just one repository, one pipeline. We're talking something much bigger. And you want to coordinate creating multiple SBOMs on multiple repositories, multiple pipelines, everything at once. And you want to be able to create subscribers so that, obviously CI/CD continuous, both of those. So you want that every time you create something new, the people who have decided to subscribe to that particular artifact would just get the SBOM. They don't need to ask for it. They don't need to wait for it. Automatically, as soon as that artifact is being created and the SBOM is created with it, they get it. They subscribe to it. So we're creating this system right now that you can both share SBOMs deliberately, create subscribers from both ends. The people who are subscribed can look at, like I said, some of those tests. They can look at, for example, if the pipeline has run successfully, how many times it broke, if there were tests that happened and didn't succeed. The more information that, again, obviously the company decides if to share that information or not, but the more information is shared, the more trust the eventual client can have into what it is he, she, it is getting. It's an interesting little system. It's built as a dashboard. Right now, we're still testing it out. But again, the idea is to make the sharing of information, increasing visibility and trust, making all that as as effortless and streamlined as possible between all interested parties.
And we've been talking about Scribe Security. That's scribesecurity.com. Nice and easy to remember. If anyone wants to find more from you, maybe these presentations you mentioned, things like that, is there anywhere in particular or on the Scribe website?
Well, on our Scribe website, there's obviously, blog posts and other pieces of information like white papers, which, I wrote or I edited after other people wrote, like an interesting piece about GitHub cache poisoning, a very technical and interesting piece that an SBOM could definitely help in mitigating. And, I have no problem sharing my personal, not my work email, as it were. And if people have any questions about what it is we do and how to utilize that technology to increase their trust and visibility, both in the software supply chain and in whatever it is they're doing, I would gladly answer those. As a DevRel, it's my job to both educate and help. That's what I'm here for, an explainer. You can definitely put my work email as part of the show notes. I would gladly help anybody I can in dealing with those issues.
I hope you enjoyed the show. Find out more about me at chrischinchilla.com, where you can find show notes, sign up for my newsletter, and find all of my writing, games, work, and video links. There's also details on how to get in touch with me. And if you want to get even closer to what I do, join my Discord server for behind-the-scenes discussions and helping me produce my shows